In this video, we'll take a brief look at a new product from the makers of AlarmTraq, which provides remote alarm monitoring on Nortel CS1000 switches. The Nortel CS1000 Alarming Gateway is a middleware product that is installed on a Windows device, micro PC, an embedded, whatever you want to use, located within the switch room of your customer's CS1000 and connects directly to the TTY port on the CS1000. The Alarming Gateway will then monitor and filter error messages coming from the CS1000, and if determined to be a legitimate alarm, will then send that alarm via HTTPS, providing encryption as well as authentication on a secure network path to an AlarmTraq web service, or optionally can be sent as an SNMP trap as a backup. So let's go ahead and get this installed, and I'll show you how it works. So I've already taken the liberty to download the installation package and extract it into a temporary folder right here on my desktop. Now I'm going to go ahead and run setup. I'm going to use all the basic default settings. I don't see any particular reason to change anything at this point. Obviously, you can accept the license agreement. I'm going to go ahead and use the default path, and we're going to install. Installation is pretty quick. It's a lightweight Windows service, so it really doesn't take up a lot of room. And the installation is now completed. It's going to go ahead and launch the program, even though I haven't given it any destination as to where we're going to be sending the alarms. So as you can see, it automatically installed a shortcut on my desktop for the settings, as well as you'll find it on your installation under CS1000. So I'm going to go ahead and click the settings. First thing it's going to show me is the filters that we're going to be applying to all the error codes as they're coming out of the CS1000. We've only got 9 filters set up right now. Some error codes that we just don't want to see. We don't care about the auto 00s or the data dumps or the time updates, anything like that. So we're going to filter them right at the source, so we don't have to waste any bandwidth by sending that information out to the web service or over the internet. So we'll leave these filters alone for now. We can add them later as we need them. First thing we want to do is identify the COM port on the local Windows PC that we're going to have attached to the TTY port on the CS1000, as well as we're going to set the baud rate. Once that's set, we'll go to the destination. When we install, the application will automatically assign a 10-digit product ID, a random product ID, that will be used to identify the CS1000 at the destination end once the error message is sent there. Not only do we need to know what the alarm code is, but we need to know what system it's coming from. The first thing it's going to want to know is the trap destination. If we're going to be sending SNMP traps, I'm going to go ahead and populate this with our development machine. 75.134.145.75. And we're going to use a community string of public. It will send the traps as SNMP version 2C traps. Now I can just send it straight as traps, or we can go ahead and use a web service. We are going to use a web service here. So I'm going to use the AlarmTraq HTTPS secure alarming.alarmtraq.com. Now I'm going to hit browse just to verify that I can actually reach the web service from here. And it looks like I can. And I can go ahead and click right there. Take a quick look. That seems to be the web service we're looking for. And now what I can optionally do is, because we're going to be sending the traps primarily up as a web service, which does provide acknowledgement of all the alarms. I can then keep my SNMP trap destination settings, but only use it as a backup if we have trouble contacting the web service. The next tab is for TCP connection, which is a future feature we're going to be using for remote access. Right now, the CS1000 Alarming application only provides outbound alarm notification. There is no remote access built in. So I've gone and entered all my information. I'm going to go ahead and click OK, which should stop and then restart the service. And I can verify that information by going to my C program files, or program files x86 if you're using a 64-bit machine. Now look at the CS1000 Alarming. And I'm going to go ahead into the logs folder. And I'm going to take a look at the event log for today. And when it first started up, a few minutes ago, it started up with no destinations there at all. It loaded all its MIB files because we are going to be sending them out using standard MIBs. Here's where it restarted. It now sees the IP address that we entered. It also sees the web service. And once it starts up, it will actually connect with the web service successfully. So we are now ready to start monitoring alarms. We're up and working. So in order to verify the operation of the CS1000 gateway, we're going to go ahead and open up our Windows services. We want to verify that the CS1000 Alarming Windows service is actually running, and we want to view the operation. So temporarily we're going to go ahead and shut down the service, stop it, and then we're going to go to the folder that contains those files, and I'm going to find the CS1K alarming.exe. This is the actual Windows service, and we're going to go ahead and start that as a console application just so we can view it. We're going to wait till it starts up. As you can see, it has the correct product ID, trap destination, and the HTTP alarming. It does connect successfully. We can see down here we are connected with the COM port on the switch because we just got in. So what we're going to do is now we're going to wait and see if anything's going to happen. I have a strange feeling that the PRI on this PRI on one of the loops on this particular switch is going to go down because they're doing some work out on the pole. Hey, look at that! It looks like DTA on loop 1, the DTA 012. The web service was acknowledged. Then it came back with the DTA 14, DTA 21. We got lots of problems on this circuit. Sure looks like it. We should be able to see those alarms now if we were to open up my internet browser so I can take a look at these alarms. I'm looking at the secure alarming on the far end of the circuit at our NOC, and as you can see, we just received the DTA 12, a DTA 14, a DTA 21, and a DTA and another DTA 12. That one's on loop 0. So let's take a look and see what these alarms actually mean. Okay, that's just the clock controller is now having a problem. The DTA 14 says that bit error rate cleared, and then the DTA 21 frame alignment. So this circuit looks like it's down right now. But looking at the guys out on the pole, I have a feeling they're going to have it fixed very quickly. So we're going to wait to see if it comes back. As you can see right now, we've got 2 alarms that are still active, the DTA 21 and the DTA 12. And now looking back here, it looks like the circuit just came back up. I see it here again, new web services. So let's refresh our browser. And it looks like everything is coming back up nicely. And as you can see, our circuits are all back up now. Loop 1 and loop 0. Yellow alarm is cleared. And looks like our clock went back into reference. And because of the way that AlarmTraq processes these CS1000 alarms, it clears all the past alarms for that particular loop. So let's go ahead and close this up, and we're going to close the console application. Start up the Windows service back the way it was. And we're good to go. The alarming is working. If you need any more information on the CS1000 Alarming Gateway, visit our AlarmTraq site at alarmtraq.com. Thank you.